Hi everyone, I'm Cheryl. In this problem, we're given the function w equals xyz, where x is s plus t, y is s minus t, and z is st squared. We're asked to find the partial of w with respect to s, and again with respect to t, by using the chain rule. And then when we're done, we're going to do it another way by converting my function w into a function in terms of s and t, and differentiating it that way. All right, so let's begin by getting the partial of w with respect to s. I'm going to take the partial of w with respect to x and then multiply by the partial of x with respect to s. Then we'll add the partial of w with respect to y and multiply by the partial of y with respect to s. Then we'll add the partial of w with respect to z times the partial of z with respect to s. All right, so when I take the partial of w with respect to x, I'll treat y and z as if they're constants, and so that partial is going to be just yz. I'll multiply by the partial of x with respect to s. So if I look at my equation, x equals s plus t, the partial is going to be 1. I then add to that the partial of w with respect to y, and again I'm treating x and z as a constant, and so that partial is xz. And then I'll multiply by the partial of y with respect to s, treating t as a constant, and so that partial is 1. I then take the partial of w with respect to z, treating x and y as a constant, so that will give me xy, and the partial of z with respect to s. So I'm treating t as a constant, which means t squared will be a constant, and that partial is just going to be t squared. Okay, so that leaves me with y times z. Well, y is s minus t. Z is st squared, and then I'm multiplying by 1. I'll add to that xz. That's going to be s plus t times st squared, and again, I'm multiplying by 1. And then finally, I have x times y, which is s plus t times s minus t, and I'll multiply that by t squared. So with a little algebra here, and I have s squared t squared minus s t cubed plus, this will be s squared t squared plus st cubed. And this is going to be s squared minus t squared times t squared if I use the FOIL on the quantity s plus t, s minus t. And so that leaves me with an s squared t squared minus st cubed plus s squared t squared plus st cubed and an s squared t squared minus t to the 4th power. Okay, so now let's see, is there anything I can combine here? I have an s squared t squared, and an s squared t squared, and another s squared t squared. So that leaves me with 3 s squared t squared. And I also notice that I have an st cubed, a negative st cubed, and a positive one. So those will add together to be 0. And the only term remaining is the minus t to the 4th. So that's my partial with respect to s using the chain rule. Let's go ahead and find the partial with respect to t by using the chain rule in a similar way. So let's do the partial of w with respect to t. This is going to equal the partial of w with respect to x times the partial of x with respect to t plus the partial of w with respect to y times the partial of y with respect to t, and then we'll add the partial of w with respect to z times the partial of z with respect to t. The partial of w with respect to x. We've already done that. That's going to be yz. And we need to multiply that by the partial of x with respect to t. So looking at my equation, I'm going to treat s as a constant, so that partial is going to be 1. Now I need to add the partial of w with respect to y. Again, I've already done that. I know that's going to be xz. And then I need to multiply by the partial of y with respect to t. So looking at my equation, I'm treating s as a constant, and so that partial is going to be -1. Then I need my partial with respect to z. Again, I've already calculated that. That's xy. And I'll multiply by the partial of z with respect to t. Treating s as a constant, I'm going to pull out the s and take the derivative of t squared, which is 2t. Okay, so now if I make some substitutions, I know that y is s minus t. And I know that z is s t squared. And I'm multiplying by 1. Next, I'm going to add x, which is s plus t, times z, which is s t squared. And I'll multiply by -1. And then I'll have x, which is s plus t, times y, which is s minus t, and I'll multiply that by 2st. Okay, doing some algebra, I have s squared t squared minus s t cubed. Here, I'm going to distribute the -1 as well as the st squared, so that'll be a minus s squared t squared and a minus st cubed. This next piece is going to be s squared minus t squared times 2st. So I've got s squared t squared minus st cubed minus s squared t squared minus st cubed plus 2 s cubed t minus 2st cubed. Okay, so let's see here. I have an s squared t squared and a minus s squared t squared. So those will add together to be 0. I also have a minus st cubed, another minus st cubed, and a minus 2st cubed. So I can combine that to make minus 4st cubed. And then the only remaining term that I have is plus 2s cubed t. And that's my partial of w with respect to t. Now that's not the only way you can get these partials. The second way is to convert my original function, which was w equals xyz, into a function in terms of s and t. So let's go ahead and do that. Remember, x is s plus t, y is s minus t, and z is s t squared. So that's going to be s squared minus t squared times s t squared, or s cubed t squared minus s t to the 4th. Now that I have my function w all in terms of s and t, I can go ahead and find the partials with respect to s and with respect to t. So let's first of all do the partial with respect to s. If I do the partial with respect to s, I'm going to treat t like it's a constant. So my expression is going to be, or my function is going to be t squared times the derivative of s cubed. So that's 3s squared. And now I've got minus, remember I'm treating t as a constant, so that'll be t to the 4th times 1. So that gives me 3s squared t squared minus t to the 4th. And if you go back and look at the way we did this using the chain rule, 3st squared 3s squared t squared minus t to the fourth. It's exactly the same thing that I got using the chain rule. Okay, let's try it for the partial with respect to t. So the partial with respect to t, this time I'm going to treat s like it's a constant. So I'll pull out that constant multiple of s cubed, differentiate t squared, that's 2t. Then again, I'm treating s as a constant, so I'll pull that constant multiple out and differentiate t to the fourth, which is going to be 4t cubed. And when I simplify this, I end up with 2s cubed t minus 4st cubed. And if you compare that to our partial when we use the chain rule, you'll notice that the order is a little bit different, but it's exactly the same partial. I hope that was helpful. Thanks.